So we will do two more examples of proving trig identities using our four strategies here. And once again, we'll always start with the more complicated side if there is one. There's not always a clear indication of when one is more complicated than the other. So on number 5, they both look about the same level, but I would say in general adding things together is slightly more complicated for trig identities than dividing them. So let's start with the left side this time. Try to make well-known identities appear. Okay, well we do have identities for both sec squared and cos squared, or cosec squared, I'm sorry. But using those I'm not sure is really going to help us, because if you replace sec squared with this, it's going to make it even more complicated. You're introducing more terms. So strategy number 2 is normally what we'd use, but in this case I'm not sure it's going to help us. Use all the normal algebra techniques. Well, think of it this way. If you're adding things together, and over here on the right hand side you have a fraction, that must mean that on the left hand side you must have added some fractions together. The only way to add things and wind up with a fraction is if what you added were fractions. So the question is, how can we change the left hand side into a fraction? And we can do it using these identities. Secant squared is the same thing as 1 over cosine squared, and cosecant squared is the same as 1 over sine squared. So let's do that, and the reason we know to do that is because we're looking at the right side and seeing that there's a fraction there. So that means we must have added some fractions together. Okay, this thing is the same as 1 over sine squared. Now what do we need to add fractions together? We need a common denominator. So in this case, this is missing a sine squared. So we will multiply top and bottom times sine squared. This side is missing a cosine squared. So we multiply top and bottom times cosine squared. So now we will have this. We will have the new denominator is cos squared sine squared for both of them. Okay, and then the top right here is going to become sine squared, and the other side will become cosine squared. And now that we have a common denominator, we could just combine them. Sine squared plus cosine squared over this. Okay, question that I have for you to think about is this. What is, supposed to be an x right there, what is cosine squared plus sine squared? And that brings us back to strategy number 2. Okay, strategy number 2 says look for well-known identities, and this is the most well-known. That's the most commonly used one. Sine squared plus cosine squared, that equals 1. Here's another strategy that I want to mention. It's not listed up there, but I would say periodically throughout this problem, look back at what you're trying to prove. So right where we are, let's pause, and let's look back up at this. We want it to be this. What do we have right now? We're in good shape because we have a cos squared on the bottom right here. That's what we want. Question is, how can we make cosecant appear? Here's how we can do it. We can split what we have now into 1 over cosine squared times 1 over sine squared. Why can you do that? Because what is 1 times 1? It equals 1. And what's cos squared times sine squared? It equals this. When you're adding, when you're multiplying fractions, you can basically split them into 1 over the first denominator times 1 over the second part of the denominator. So what's another name for 1 over sine squared? This is the same as 1 over cos squared. That's coming from right here. And another name for 1 over sine squared is cosecant squared. How did we know to change that into cosecant squared? Because I'm looking up here and seeing that there's supposed to be a cosecant squared. And then if you multiply these, cosec squared times 1 is that, and cosine squared, and it's still on the bottom, is that. So we have cosec squared over x, or cosec squared of x, I'm sorry, times cosine squared. That is equal to the right hand side. We started with the left hand side, we changed it, now it's identical to the right hand side. Alright, number 6 is similar type of thing. We have to start with the more complicated side. I would say definitely the left hand side is more complicated because you have multiple things in the denominator. Try to make well-known identities appear. There is no well-known identity that has that only has cotan and tan, so that's not really going to help us. Use the normal algebra techniques, factoring, using the conjugate, etc. Okay, well we could do that. The conjugate might make it a little bit more messy than we want though. So I would say the best thing to do is this right here. When in doubt, change everything into sines and cosines. So let's look at our identities. Cotangent and tangent can both be expressed in terms of sine. So we're going to pick the left-hand side right here, and we will do this. We will say sine of x over, this is the same thing as cosine over sine, and this is the same thing as sine over cosine. Now we have some fractions that we can add. the common denominator would be sine times cosine, so this is missing a sine. This one is missing a cosine, and now this problem becomes very similar to the one that we just did. So we have sine of x on the top. We have our new denominator. I'm just going to combine these. Our new denominator is cosine times sine. This right here is cos squared, so that's going to go right here. And I'm just skipping a step. We're combining these because we already know it's a common denominator. This is sine squared, so plus sine squared. What is cosine squared over sine squared? It equals 1, just like we saw before in that last problem. So we can now simplify this a little bit more. We can say this equals sine over this thing right here just becomes 1 over cosine times sine. And now we can use strategy 3, use our regular algebra techniques. What do we do when we're dividing fractions? We use that phrase copy dot, and then some people say flip, some people say flop. Copy dot flop. So I'm going to copy sine, make a dot for multiplication, and then flip 1 over cosine sine to become cosine sine over 1. Sine times this sine becomes sine squared. And we have times cosine. Now's a good time to look back at what we're trying to prove. Well, we have the cosine right here, so that's a good, pardon the pun, but that's a good sign. Cosine over, and then we need an over cosec squared. So how can we do that? We could say cosine, and then another way of saying sine squared, another way of saying that is 1 over cosecant squared. So we have 1 over cosecant squared times cosine. That's the same thing as cosine over cosecant squared, and that's exactly what we wanted to prove. That was the right hand side, so we're done. We proved it.